The name of this podcast is Alcohols. It is the second topic that we are discussing in term 3. The assessment criteria for this unit is as follows. You should understand the oxidation of alcohols and their products. You should understand the two main routes for ethanol production, and you need to address the environmental issues of the use of ethanol and understand the concept of carbon neutrality. Alcohols can be oxidized. These alcohols are normally oxidized with sodium or potassium dichromate or another significant oxidizing agent. You can see the electron half equation below. It's a half equation because it's an oxidation reduction reaction. Primary alcohols are those alcohols that are connected to a carbon with no other additional carbons where hydrogens might be. Look at ethanol below. You'll see that on the carbon that has the OH, there is an H above it and below it, and a CH3 to the left, naming it by its longest carbon chain. There's two. It is ethanol. What happens when we oxidize a primary alcohol like this is we pull out a water, as you can see in the balanced equation, and create an aldehyde. If there is sufficient oxidation material, the aldehyde will continue to oxidize and turn into a carboxylic acid. This is a secondary alcohol. You can tell it's a secondary alcohol because instead of one of the hydrogens on the last carbon, there is a methyl group. So the carbon that has the OH on it has two methyl groups attached to it, or two carbon groups attached to it. So therefore, it's a secondary alcohol. Again, we can pull out water, but there is no way to go beyond a ketone. In this way, propanone. There is no more oxygen that can be attached. Oxygen will not attach to the methyl group. So in a secondary alcohol, we can only go one step in creating a ketone. You will see now the differences between primary, secondary, and tertiary alcohols. In a tertiary alcohol, there is no hydrogen attached to the carbon that has the OH group. Therefore, there can be no pulling off of a water. There can be no oxidation of a tertiary alcohol. Ethanol can be made in at least two different ways. And these are the commercial ways that they are made, from ethene and from fermentation. Ethene can be found near the production of petrol and diesel in oil refineries. And oftentimes, ethene plants have alcohol plants attached to them. You see that you take ethene, move it over steam at 300 degrees Celsius and 60 or 70 atmospheres with phosphoric acid, and you can create ethanol. You can also create ethanol by the fermentation of cellulose or carbohydrates. This diagram gives you an idea of how ethanol can be made by fermentation. We'll show a video in class that discusses this in depth. We will show a video now, though, that gives these two processes in simplified form.
There's a great demand for alcohols in industry. We use them to make antifreeze for our engines and for antiseptics to disinfect the skin. If you've ever used a hand sanitizer that works without water, that will have contained an alcohol. We also used a 2-carbon alcohol, ethanol, as an ingredient in alcoholic drinks. The alcoholic drinks industry is huge, and making beer or wine requires science. The process for making alcoholic drinks is called fermentation. The reactant in fermentation is sugar. It comes from natural plant extracts, barley in beer making and grapes in wine making. These sugars have the general molecular formula C6H12O6. Fermentation converts them into ethanol and carbon dioxide. You might notice this equation isn't balanced yet, so have a go as a mini challenge. Pause and continue when ready. Here's the answer. The problem is, this reaction happens far too slowly to be of use to industry, but it can be catalysed by the enzymes of a naturally occurring fungus called yeast. Let's move on to our second route. This one also makes ethanol, this time from a hydrocarbon called ethene. You might have come across it in our videos on hydrocarbon cracking. Here's the ethene molecule and its molecular formula. Here's the ethanol molecule from before. Now look at the numbers of each atom on both sides. Can you think of a very common molecule we can add to ethene to produce ethanol? Again, pause and think, then resume. Well, the answer is the good old water molecule. It's reacted with the ethene in steam form, and the ethene double bond breaks open, allowing addition of H2O. Phosphoric acid is used as a catalyst. Note that ethanol is the only product in this reaction. The ethene route is faster and more efficient as there is no waste product formed, only the useful one. Fermentation also yields carbon dioxide, which isn't useful to us. But ethene is cracked from crude oil, which is a non-renewable resource, so we won't be able to carry on acquiring it this way forever. Plant sugars, on the other hand, are a renewable resource. The ethene route also requires much more energy. The initial crude oil must be heated to a high temperature, and so too does the water to create steam. The fermentation route requires heating only to 37 degrees.
There are advantages and disadvantages in the production of ethanol. Some of the obvious advantages are cost, the source, you'll always have the ability to grow crops, the security, you can grow crops on your own nation's land, and lower carbon emissions. Disadvantages, probably the most important is that biofuels have a lower energy output than oil. So you need more of the biofuel. There can be cost issues in building the infrastructure, the plants to make the biogas and the ethanol. If you're using biomass for the making of biofuels, then food prices might go up. And in order to raise the biomass, you need large amounts of water. If to get an idea of this concept of the use of biomass, carbon neutrality has become a popular word around the world. That carbon neutrality is having a net zero carbon footprint for each individual on their use of energy. The mechanism of carbon neutrality is probably best described in the following video.
Carbon neutral. You may have heard the term before, but what does it mean, and how can we help you work towards it? Well, fossil fuels contain carbon, and when you burn them, you release carbon dioxide, or CO2, into the atmosphere, creating a greenhouse effect, which warms the planet, bringing with it a whole host of problems. For a long time, we've been emitting greenhouse gases into the environment, burning fossil fuels when we use electricity, drive our cars, and every time we fail to recycle. So most of the time you power something up in your life, CO2 is released. It's only relatively recently that we've realised the folly of our ways. Carbon Neutral is here to help, whether you're a business or an individual. We help you calculate your carbon footprint and reduce the amount of energy you use. We then offset the CO2 that is left through tree planting programs or investments in clean energy projects. Basically, when you offset what you emit, you become carbon neutral. You see, trees grow by taking in CO2 and holding it as carbon. The more trees, the less CO2 in the atmosphere. At Carbon Neutral, all of our tree plantings take place in Australia. A biodiverse mix of local species is used to revegetate partially degraded, cleared land, providing a habitat for local fauna and flora.
Here are some questions to start your thinking. Please complete these questions and provide to your teacher before you retake the formative.